Good afternoon, everyone, and thanks for taking time out of your day to come and join our webinar, which is about the importance of service engineering to the future of mobility. My name is Neil Montgomery, and I'm a service lifecycle consultant at CAD-IT. I'll give you a little bit of my background. I've worked at CAD-IT for the last 5 years, and in that time, I've worked with many different customers in many different areas of service. And as I said at the start, we're going to talk about service engineering, or SERP as we call it, and its importance to the future of mobility. Before I just go into the webinar, I want to give you a bit of an overview of CAD-IT. So CAD-IT, at CAD-IT, our mission is to supply industry-leading or world-class Industry 4.0 solutions to our customers to help them reduce their costs and improve their quality and productivity. Our company is a privately held group with over 600 employees, and our headquarters is in Singapore, but we have regional offices in the US, the UK, Europe, and all over Asia. We currently have 125 international awards, and as I say, we're specialists in Industry 4.0, and that includes design, simulation, manufacturing, PLM, SLM, and tech pubs and service consulting. So a bit of a broad range to cater for everyone's needs. The industries that we work in, again, are quite broad. So we're in aerospace, automotive, industrial equipment, heavy machinery, medical, marine, EV, autonomous, and agriculture as well. So again, catering to as many customers' needs as possible. So if I covered this in the last webinar, and I just want to cover it again, what is mobility? Well, really, in the last 120 years, mobility hasn't actually changed that awfully much. It's always involved the manufacture of internal combustion engine vehicles, which are sold and serviced by dealers for customers. But I guess in the last 5 years, mobility has started to change quite rapidly. I think as a result, there's been a lot of OEMs and startups that have moved into the EV and the autonomous market. And despite the influx of companies moving into that market, there's not necessarily enough room for them all to survive, and definitely not enough room for them all to thrive. So in order to do well in this industry, or in the mobility industry, companies need to adapt and change the ways that they manufacture and design vehicles. It has to be cost effective, otherwise they just won't survive. So service engineering, basically it allows OEMs to ensure that the maintenance of their vehicles is as cost effective as possible. So we'll talk a little bit more about service engineering as we go through. So first of all, what is service engineering? So service engineering, also known as SERP, plays a significant part towards customer satisfaction, warranty, cost reduction, and product reputation. The serviceability of a product is influenced by the design and package of components and assemblies. So these directly affect an OEM's capability to perform an efficient service or repair. What a SERP engineer or a service engineer does is they assess a design for 6 key attributes, and then they provide feedback to the design team, who have to consider the assessment that the SERP engineer has made. So what I'm going to do now is kind of talk through what those 6 key attributes of service engineering are, and why they're important. So number 1 is accessibility. So access to components is really key to service. So it's not just hand access, it's also tool access. Because if you don't have access to a component, you can't service it or you can't remove it. Therefore, a SERP engineer will have a look at the design and make sure that all of the serviceable components are actually accessible. The second on the list is location. So the initial design that's provided to service engineering all of the components may not actually be visible to technicians, and a lot of the time that's not really an issue, but it is an issue when those components need to be frequently serviced. So if a technician can't see what he needs to service, can clearly see it, then the maintenance of that part actually becomes a lot more complex and takes a lot more time. So it's in a service engineer's best interest to make sure that everything is clear to see. Next is obstructions. So the obstructions pose a similar challenge to accessibility, per accessibility. So if a technician has to remove lots of different parts that don't necessarily need to be serviced just to access the part that they do want to service, again, it takes up a lot of time, complexity, and it actually introduces the possibility for more problems later on down the line. And that obviously ends up with higher warranty bills and increased customer dissatisfaction. So yeah, that's obstruction. Sorry. Next on the list is orientation. So orientation is particularly important when you're servicing parts or assemblies that need to be removed to service fluids, so like coolant or oil. In particular, if the orientation is correct, you also need to consider whether the fluid can be captured. And if it does spill or if it leaks, where is it going to end up? Or is it going to end up somewhere that could cause a problem later down the line? So that's why orientation is also very important. Fasteners. So fasteners are important again, because if you don't have standard sized fasteners, you end up requiring lots of different tools to remove these components, but also it takes a lot more time to actually end up removing something, or it's a lot more complex to remove something than it needs to be. So ensuring that your fasteners, your nuts and bolts, clips, etc., are all uniform or as close to uniform as possible can make service more efficient. So a SERP engineer will always try and make or talk to the engineers, the design engineers, to make sure the fasteners are all quite uniform. And then finally, tools. So the number and type of tools required to perform a procedure has a direct impact on the ease and quality of repair. So SERP engineer needs to make sure that as few tools as possible are required to actually perform the service repair operation. And in particular, at all costs, you should avoid special service tools, because it just ends up costing the company more money to design and manufacture and distribute special service tools. So those are the 6 key aspects that service engineering has to consider when assessing a design. Okay. Good. Now we're going to talk about why service engineering is important to the future. So we touched on this previously in the service strategy webinar, and that mobility is changing for a number of reasons, mainly societal reasons. But what this means is that OEMs are having to change how they design, manufacture, and operate their vehicles. And there are a number of considerations, but 4 of the key considerations for OEMs looking forward to this new era of service are. And we'll go through them and I'll talk about each of them a little bit. But the 4 of them are life cycle longevity, vehicle uptime, service efficiency, and warranty cost. Now, all of those may already have been considerations for OEMs, but because of the competition in the market and the way that mobility is changing, they're becoming more important. So with life cycle longevity, because of this transition to mobility as a service, OEMs are starting to view their vehicles as operating assets. So in order to maximize the return that those assets make, they need to maximize the life cycle that the vehicle has. And therefore, it is essential that the vehicle is designed for regular service and maintenance, so that parts don't wear out as quickly, or that the actual vehicle can stay in service for as long as possible. So it is the job of the service engineer to recommend the appropriate service intervals and prolong the vehicle's life cycle. Next, we've got vehicle uptime. So reducing the amount of time that a vehicle spends being maintained. So although it's maintained more often, we need to reduce the amount of time that it's actually in the dealership spent working on. So that's crucial to maximizing revenue for OEMs. And a SERP engineer does this by influencing the design and packaging of the components, as I talked about earlier on. So your orientation, your accessibility, and the location of components. So that's how they'll influence that. Thirdly, we have service efficiency. So typically and traditionally, OEMs will always focus on making sure that the vehicle or their asset can be designed and manufactured as efficiently as possible, with lean manufacturing, etc. But what doesn't tend to happen is that people focus on making service and maintenance as efficient as possible. So it's really, really key that the same approach is taken to making service and maintenance efficient. Not only will it help with maximizing uptime, but it'll also reduce the warranty costs later on, and actually it improves the morale of the staff who are working on the vehicles, because a lot of the time people forget that if you go to work knowing that you're going to have a really arduous, complex day, getting covered in oil and stuff, it's not great for morale. So making a straightforward service is. So finally, warranty cost. So as I mentioned previously, the growing competition in the mobility sector means that companies need to minimize their warranty spend to be able to survive. So service engineering is by far the most effective way to do that, to reduce labor time costs and also ensure that the correct procedures are in place to prolong the life of the vehicle. And we'll talk about that a little bit more in the next few slides, and I'll show you examples of how service engineering can save that money. So I've got a little graphic here, which is pretty simple, but basically this graphic depicts how important service is to the financial success of a product. And what we've got here is with the dashed blue line, is essentially if an OEM doesn't consider service during the design and manufacture of a product, then the amount of effort and cost will be high for the remainder of that service life cycle. And usually the service period is much longer than the design and manufacturing period, so it ends up costing a lot more than it needs to, really. So the white line is just showing that if service is considered early during the design and manufacture of the vehicle, then the warranty costs will be kept to a minimum, allowing them to maximize their profits. So this was just a quote by Henry Ford, that a business absolutely devoted to service will only have one worry about profits, and that they'll be embarrassingly large. So I just thought it was a nice little graphic. So if we move on now to just to show you a working example of a past project that we were involved in, and I've only taken a snippet of the data. I just thought these were three really good examples of how SERP engineering saved a huge amount of money. So this example, as I say, it only includes 3 service operations. However, we made many more savings for this customer. But to give you a bit of the backstory, this customer manufactures around 3,000 vehicles per year, or 3,000 vehicles per year go into service. And these vehicles do quite high mileage, and therefore the service operations listed have to be done every year. So the vehicles come with a 5-year warranty, so it's over a 5-year period that the OEM is paying the warranty bill on these. And So in red, you can see the initial repair time. So this, when we were first given the design data from the customer, we assessed it, and these are the times and hours it would have taken to do these repair operations. So an air conditioning regas would have taken 4.8 hours, coolant refill 3.5, and a HVAC filter 2.1, which are all crazily high. But it's because when engineers are designing these systems, and they're designing them in isolation, so they don't understand, or they don't have clear sight of what other people are designing around it. So to actually access a lot of the components to do these procedures was going to take a huge amount of time. So in the green here, you can see after our SERP engineer assessed the design and the proposals that we put forward for the design changes were implemented, we got them all down to less than an hour. And what this resulted in, I guess the bottom line is that we save them £191 per vehicle per year. And the graph here actually depicts what that saving is over a 5-year period, when they've got 15,000 vehicles in service. And, it's almost £3 million just for those 3 tiny regular procedures. So that's just, I think essentially what I'm trying to get, or trying to show you, is that for a small investment in SERP engineers, or a SERP engineer, you can save your company millions over a very short period of time. And not only, it's not even just about saving the money, it's about making your dealer network, or giving them products that are easily serviceable, and keeping your customers happy, because it's obviously less downtime for them as well. And I suppose if you're in the commercial industry where you're servicing, say, lorries or buses or whatever, time is money for your customers as well. So yeah, it's a really good example of this. So I just wanted to talk about our end-to-end approach, our CAD-IT's end-to-end approach. So obviously previously we talked about service strategy and planning for service. And this webinar is more about service engineering, or SERP engineering, which you can see is the second step in our end-to-end approach. Obviously, once we have when we do our service engineering and it's complete, we'll then start to look at introducing a solution to create content. This is for outsourcing. So we would then take all the data that we've evaluated with the service engineering, and we've got the final design. We can then start to create content, technical publications content, which can then be used for both training and service operations out in the field. So this is a CAD-IT's end-to-end approach to the service lifecycle. And finally, I just wanted to recap on the takeaway points that I've covered today. So obviously mobility is changing, and there's no getting away from that. Things are changing rapidly, especially in the EV and autonomous market. And what we're starting to recognize is that for a product to be successful, it needs to be service needs to be considered right throughout every stage of development. It can't just be an afterthought, which is what it usually is. Service engineering enables OEMs to maximize the efficiency of their service and repair operations. And finally, a small investment in service engineering resource can save a company millions of pounds in warranty. So those are really the key takeaway points from today. And I'd love to hear if you guys have any questions, and please do be in contact. Even if you don't want to ask a question now, I can answer them over email. So please be in contact. So if anyone has any questions for me now, that would be great.
So we've had a few questions come in. The first one is, at what stage should service engineering get involved?
Okay. Yeah. So service engineering would ideally should be right from the start. They should be involved right from product inception. There is a period of time where it's okay if they're not involved, but as a design, the more mature a design gets, the less value that service engineering can add, because obviously there's hard points in your gateways and your planned deliverables. So the earlier the better, essentially. Is there any?
And the second question is, how do they check for accessibility if there is no physical product to test on?
Very good question. So there's actually two methods. Our more traditional method is obviously we're using the same CAD that engineers are using, but there's an add-on to a lot of the CAD software packages, which is known as a jack. So it's an anthropometric hand or ergonomic hand, and we manipulate the hand to make sure that it can fit in the different spaces in and around the vehicle. But more recently, it's quite a time-consuming process, that because you have to manipulate each finger and introduce tools and things. But more recently, we have started using VR, virtual reality, and we can use a headset and we can see the CAD data in front of us, and we've got the same hand, the same jack hand, and we can in real time move it around and check spaces, so it's a lot quicker as well.
Okay, I think this might be the last one, which is, why do companies need a SERP engineer when design engineers should spot some of these problems?
That's a really, really good question. So typically, I think I covered it partly during the session, but typically engineers design in isolation. So that, you might have chassis designers and powertrain designers, and they're designing their part to fit in a certain space, but they don't necessarily consider each other's work. And that's where you start to get clashes and per packaging. So what a SERP engineer does is he or she evaluates the whole design, and not just that one specific area. And that is what makes them unique to it. And also typically a service engineer or SERP engineer, as we call them, will have had a practical experience, or we at CAT-IT like to employ people who have had practical experience of service, so they understand the challenges that technicians are facing.
I think that's it from the questions.
Okay, great. Well, as I say, if anyone's interested, please drop me an email, because I'd love to hear from you and I can answer you more questions and we can go into more depth, maybe do a demonstration on how SERP works.